So number 20, this is a bit challenging because we already have a previously transformed function. The fact that it's a square root function is really quite irrelevant. We're just going to look at the transformations. But we already have a previously transformed function. On the outside is the previous transformation is 5/8 compression. And we need to make it transform it into a 2/5 compression and a vertical flip, and also shift it down 4. So we're going to start with the y's first. Okay, so there's transformations in the x as well, but we're going to start with the y's first because the y's are a little bit easier to work out. And for the y's, what we're going to do is we're going to first of all match the shape. So we want to match this shape into this shape. So we want to flip it, and then we want to multiply it. In this case, it looks like the factor is going to be, we need to get rid of the 8 and have a 2 in the top, so we're going to have 16 over 25. So, and we can work that out this way too. We can go 5/8 times some number is equal to -2/5, and we can solve for that multiplying factor, and we get -16 over 25. So I'm going to first of all do a vertical flip and then a compression of 16 over 25, and that will go from 5/8 to -2/5. Okay, so I'm going to do that to the y, but then I also need to shift it into place. We always want to do the times first, and then we want to do the plus minus second. Okay, because it's easier to get the shape first and then shift it into place. So that's what I've done here. So our transformation is going to be a vertical flip. It's going to be a vertical compression by 16 over 25, and then it'll be a vertical shift down 4. So that's our horizontal, that's our vertical. Our horizontal is a little bit tricky because we have to actually think everything backwards. And one way to do this backwards is really just to keep track of our old x and our new x. So in our transformed expression, this really is a new x. This is what we want to find. This is what we want to get to. And this is our old x here. So I can actually just solve for xn. Now try to understand the reasoning behind this as well. What this -7 over 12 onto the old x does is it gets me back to neutral. Okay, because remember this is -7 over 12 is actually opposite. So well, if I do that actual 7 over 12, I get back to neutral. So I get back to where I started at square root x. And then I can do all my other transformations. I can do my compression by 6 and then a shift left 3. So if I solve this, the first step is just going to do that, whatever is already here. Okay, it's going to apply that and it will get back to its neutral position. And then if I solve for the new x, I now do the transformation from my neutral position. So I'm going to get it down to, I'm going to compress it by 6. And then I'm going to shift it to the left 3. So the first thing is going to be a horizontal flip. I'm going to do a horizontal compression by 7 over 72. Okay, and that 7 over 72 reflects the original 7/12, and then also a horizontal compression by 6. And then lastly, I'm going to do a horizontal shift left 3. Okay, and so this x transformation, if you remember this process, if we could just make the insides equal to each other, if we solve for the new x, we will get the transformation from the previously transformed function all the way to the new function. And this is kind of a easy way to be able to set up this problem. Now, understanding why it happens is a little bit complicated, but actually once you know how to set it up and solve for the x, the process is very easy, and then we get our solution very nicely.